Hello, welcome to class. It's nice to have you once more. In today's lesson, we are looking at the periodic what? Table. What is the periodic table? The periodic table shows the arrangement of elements into rows and columns showing their chemical what? Properties. From the periodic table, we can determine the chemical properties or the properties of elements in each group and what? Period. Why is it called periodic? It's called periodic because the properties keep repeating itself when you move either from left to right or from up to down. Now, when I say move from up to down, we call it a group, and when you move from left to right, we call it a period. The elements are always arranged from the lighter one to the heavier one, either from left to right or up to down. Okay, the periodic table gives us a lot of information. All right, it gives a lot of information from the periodic table. We can determine the properties of the element because of the period or group it belongs to. Each element are arranged in a square. Within this square, you have the symbol of the element, which is called the chemical symbol, and then some symbols are written according to their name, while others are gotten from their Latin name, like silver. You see there is not written as what? Silver. The Latin name for silver is argenti, while that for lead is plumbum. Hence, you are seeing those symbols in Latin. And then at the top, you have the atomic number, which represents the number of proton of the element. And beneath it is the atomic mass, which is the average mass of the atoms. Okay? The elements at the left are generally called what? Metal, with an exception of hydrogen there. Okay? The metals in group 1 are called the alkali metals, while those at the left of my right hand side are called the non-metal. Hydrogen is also a non-metal, but hydrogen is placed in group 1 for convenience. Okay, take note of that. Hydrogen is placed in group 1 for convenience. Now, the thick block you see between the metals and the non-metals, and the element under and above those thick block have another classification, and they are called metalloids. They have the properties of both metals and what? Non-metals. Or we can say they have properties in between metals and non-metals. Like I said earlier, the periodic table allow us to identify the properties of what? The element because of the period and the group they belong to. You must note here that these elements are actually arranged in order of increasing atomic number as you move from left to right or from top to bottom. Why is that so? It is discovered that when you arrange them in order of increasing atomic number, which of course is the number of proton, a term known as periodicity occurs. That is, the elements are, repeating themselves in the same pattern. Do you get it now? Yes, and this term is what results to what we call the periodic what? Law. The periodic law states that the properties of the element are a periodic function of the atomic number. All right, when we look at the periodic table, the first column is called the group. We have 18 group of the long periodic table, and then we have 8 group of the short periodic table. Okay, elements in the same group have the same number of valence electron in the outermost shell. Okay, while those elements in the same period have the same number of shells. Okay, what you call energy level. Okay, the group 1 element are called the alkali metal, while the group 2 are called the alkali earth metal. We have the S block partially filled, and they are called the S block elements, while group 3 to group 0, group 8 are called the P block element because they have the p orbital. Group 18 or group 0 have completely filled orbital. Now, in between group 2 and group 3, you have the transition metal, which of course are d orbital being filled, and then at the bottom you have the inner transition metal, which consists of 2 rows and 14 columns. Okay, it consists of the lanthanide and the actinide series, which have their f block orbitals what being filled. All right, the development of the periodic table began after chemists held a meeting that there is need to organize these elements because of the ambiguity of describing the elements, and A series of scientists tried. We have Dombeриnas, we have Newland, but it was Dmitry Mendeleev whose work brought breakthrough to forming the periodic table. He arranged the elements in order of increasing atomic mass. Take note of that. Dmitry Mendeleev's periodic table was arranged in order of increasing atomic what? Weight or mass. Research argues that at that same time, J.S. von Meyer also discovered the same math pattern, but the accreditation is given to Dmitry Mendeleev because of so much dedication and effort he put into making this discovery. Why is Mendeleev's periodic table so unique? Why not Dombeриnas and Newland trial? Why? Because Mendeleev was able to do two things. One, he created blank for all discovered elements and also predicted the properties of this element. It will surprise you to know that when the scientists discovered eco aluminum, which is called gallium, he first of all sent a wrong atomic mass to Mendeleev, and Mendeleev told the scientists that your measurement is wrong, do it again. And then the scientists had to do the measurement again, and Mendeleev was correct. He also altered his own arrangement of atomic weight, for example, placing tellurium before iodine and also placing cobalt before nickel, thereby maintaining the chemical properties rather than the atomic weight, which was later found to be correct. This also enabled him to arrange the noble gases into a new column, because as at that time the noble gases were not discovered. Now the anomalies of Mendeleev's periodic table was corrected by a young scientist known as Henry Moseley, who was a student of Ernest Rutherford. Okay, Moseley carried out what we call X-ray diffraction on all the discovered elements and discovered something new, that each element had a unique barcode which rises by constant from the lightest element, hydrogen, to the heaviest element at that time. And then Moses predicted that the elements are actually not arranged in order of increasing atomic mass, but rather increasing atomic number. And of course, this puts the element into the periodic table into life, showing that the alteration that was made by Mendeleev initially were actually correct. So the elements are no longer arranged in order of increasing atomic mass, which they thought, but rather a secret number known as the atomic number, which represents the number of what? Proton. Now, what Henry Moseley did was, enable us to know the total natural element that were available, those that are yet to be discovered, okay? And subsequently, these elements were what? Discovered. We now know that we have 92 naturally occurring elements, and the rest being artificially synthesized, okay? And there are no more natural elements. Though scientists are speculating that they might still be able to synthesize more new artificial elements. This video will allow you to learn more about the development of the periodic table. Take note of Dombeриnas triad and Newland's octave or law of octave, okay?
And you are given a copy of this in your exam. The periodic table is arranged into columns, which we call groups. So we've got group 1 and group 2. We then have this big block, which we call the transition elements. And then we have groups 3, 4, 5, 6, 7, and finally group 0. So why is it called the periodic table? Well, the word periodic means occurring at regular intervals, and in the periodic table we can see that elements with similar properties occur at regular intervals. So for example, we can see that group 1 consists of highly reactive metals such as lithium, sodium and potassium. On the other side of the table, group 7 consists of highly reactive non-metals such as fluorine, chlorine and bromine. All of the elements in a group have got similar chemical properties, and that means that they react in a similar way. That's because all of the elements in a group have the same number of electrons in the outer energy level. Coming up, we're going to look at two scientists who made early attempts to arrange the elements into some sort of order. Okay, a long time ago, scientists began to see if they could put the elements into some sort of order. The scientist Johann Dobereiner noticed that elements with similar chemical properties often occurred in threes, and he called these triads. A good example is lithium, sodium and potassium. these three metals all react rapidly with water. Dobereiner noticed several other triads such as chlorine, bromine and iodine. These are all reactive non-metals. So from this, scientists began to wonder whether the elements could be arranged into some sort of logical order. Around 40 years later, the scientist John Newlands noticed something really interesting. He arranged the elements in order of increasing atomic weight. He saw that every eighth element reacts in a similar way. If we count lithium as element 1, then element 8 is sodium. If we now count sodium as element 1, then element 8 is potassium. We can do the same with beryllium, magnesium and calcium, and again these three elements also react in a similar way to each other. Newlands called this as law of octaves. Now Newlands' system did have problems. By always sticking to the exact order of atomic weight, sometimes elements were grouped together when they had totally different properties. So that meant that Newlands' law of octaves was not really taken seriously by other scientists. Coming up, we're going to look at the work of the Russian scientist Dmitry Mendeleev. Okay, I'm showing you here the scientist Dmitry Mendeleev. Mendeleev developed the first modern periodic table, and you've got to be confident about how he did this. Mendeleev started by arranging all the elements in order of increasing atomic weight. However, he then did two things that no one had done before. Firstly, if he needed to, Mendeleev would switch the order of specific elements so they fitted the patterns of other elements in the same group. Secondly, Mendeleev realized that some elements had not been discovered, so he simply left gaps in his periodic table where he thought an element was missing. Mendeleev was so confident that his table was correct that he actually predicted the properties of the undiscovered elements based on other elements in the same groups. Several years later, these elements were discovered and their properties matched Mendeleev's predictions. Because of that, other scientists now accepted that Mendeleev's table was correct. The modern periodic table is almost exactly the same as Mendeleev's, apart from a couple of important differences which you need to know. Firstly, in the modern periodic table, the elements were arranged in order of atomic number, in other words the number of protons. When Mendeleev developed his table, protons had not been discovered, so he ordered the elements by atomic weight. The problem with doing this is that elements can appear in the wrong order due to the presence of isotopes. Secondly, the modern periodic table has group 0, the noble gases. These had not been fully discovered when Mendeleev published his table. Okay, so hopefully now you can describe early attempts to arrange the elements into a periodic table. You should then be able to explain why Dmitry Mendeleev's periodic table successfully predicted the properties of elements. And finally, you should be able to describe how the elements are arranged in the modern periodic table.
That now brings us to the end of today's lesson. Now, next lesson we'll look closely into this element and their periodicity. Remember to subscribe.